So, I'm here today to talk about the Paleozoic, Mesozoic, and Cenozoic eras. And I apologize that the recording has to be done on my phone, but I don't have a lot of other software that can help me present. So, nonetheless, we will push forward. So, we start with the Paleozoic era, and I'll let you sort of look at this for a little bit because it's helpful to sort of see all the periods and in the Paleozoic timeline and just sort of take a gander at it. And if you really want to look, you can look at the different epochs too, but we won't be getting into those because I need to move quickly on this one. So here are some more boundaries because they're helpful to sort of know. Most of these boundaries mark mass extinctions. That's usually what ends a period and begins another. So first we start with the Cambrian. And the Cambrian's really cool because this is where life started to take off. Like before it was like simple. When I say simple, I mean really simple. And like phytoplankton and stuff like that. But we start to see like arthropods, like trilobites. Those are kind of like the staple, or like the when somebody thinks about Cambrian, they think about trilobites, and we can also see them still today, which is amazing. If you want to like look it up, it's just the Google horseshoe crabs, and we also start to see stuff like mollusks, like nautilus and stuff like that, and we also see more complex things like joints and shells being developed at this time, which is crazy because before there's never been something like this or so complex. And the end of the Cambrian also ended with, you probably guessed it, an extinction. And this one was due to a decrease of oxygen. At the beginning, the reason why life popped off was because of oxygen. And with the limiting of it, a lot of the ocean life died at this time because there also wasn't any land life at this time. And this began the Ordovician. Land life sort of was established at this time. By life, I mean there was a small plant that grew on land, and it was pretty uncontested, so it covered a lot of the earth. But the ocean life at this time was just being more complex. It was developing. You start to see like these big pointy squid-looking things, and sort of fish and vertebrae were starting to emerge. And but let me talk about that plant, or let me go back to that plant. That plant, since it was so uncontested and it soaked up a lot of the CO2 that was in the world, there was and therefore made less greenhouse gases, then the world got a lot colder, and there was nothing to stop the plant from doing this. So it led to a sort of ice age and caused another extinction because life wasn't ready to get that cold that quickly. And this began the Silurian. And at the beginning of this period, it was kind of cool because some of the first fungus was ever fossilized. I don't even know how, because if you ever think of like a mushroom or something, you're not like, this is a hard bony plate thing that, is really good for being fossilized. They're very squishy and, not complicated and have hard bits. And something that was cool about the fish at this time is some of the more dominant, they weren't dominant yet, but some fish sort of developed jaws. And if you think about today, a lot of the fish we have, if not all of the fish we have jaws, which will lead into the next period. And the end of the Silurian also was marked with a couple other minor extinctions, and most extinctions are either like lack of oxygen, temperature change, or just other chemistry not agreeing with life, and that's basically what it was. And that brings us to the Devonian. And so when I was talking about jaws, if you look at this guy in the bottom right, follow my cursor, he is the early precursor of most fish and whales. I don't know many of the fossils by name, so I'm not going to try and guess this one. But also another cool thing at this time is trees were starting to happen. Like plant life has sort of progressed to a certain point where it wasn't just that really simple like green little patchy thing on the ground. It was able to form like trees, and with trees, you start to develop like early ecosystems, and that was really key for life on land. And also, the vertebrates at this time were also trying to make it onto land. And you see this guy in the upper right. Scientists don't have any fossils of it like living on land. It doesn't have any land fossils, but there are a lot of marks that are from it, or people think are from it, and those have been preserved, and it was on land. So that's most of the early life was pointing towards that in particular, and that's really neat to see because it was mainly just insects on land at this time. They're kind of like arachnids and other plated insects. And at the, I can't remember exactly what. Oh, no. I know what happened. What happened was there was a decrease of oxygen, and a lot of life also died again, and then it marked the beginning of the Carboniferous period. And the cool thing about the Carboniferous period, you can probably infer from the name, is a lot of the tree life diversified, and there's a lot more oxygen on land, and it led to a sort of like golden age of sort of development, because you can see that fish that was there before has now grew like legs and other things like that. And also another cool thing about the vertebrates being on land is these early form lizards started making eggs with calcium shells. And you might be like, oh, what does that have to do with anything? But before, they were pretty much limited to immediate range of water because their eggs needed to be in water to survive. But now with the calcium, they can just lay them wherever on land, preferably in like a safer location. But now like they were starting to spread to more arid areas because nearing the end of the Carboniferous period, Pangaea was starting to be formed, or a supercontinent. And this means that there's a lot less like water around all the perimeters because it's one big continent, so everything in the middle is going to have limited access to water, whereas before most of it was just island life. And this is really important because this is how a lot of the lizards and life was established in those more dry areas. And also, since there's drier areas, and there can still be a dry and cold area, glaciers were starting to form in those places too. And the end of the Carboniferous ended with another just lack of oxygen, trees dying, life dying, but not all of it was killed, so it was able to make a resurgence. And that begins the beginning of the Permian. And something cool about the Permian is there's this Dimetrodon over to the right, and that is one of the earliest forms of mammals right there. I know he doesn't quite look like it, but just take my word for it on this one. And since this supercontinent was like fully formed, a lot of deserts and glaciers were really sort of coming to fruition during this period because they're also like slower processes too. So if it begins at the end, or if it starts sort of forming at the beginning of the Carboniferous period, then it will fully form in the Permian and sort of establish itself. And there was also a lot of smaller lizards too that will be important for the final point of the Permian. And the final end part of the Permian is it was part of the Great Dying, it's called. And it was crazy because it was also, first of all, it was a climate change that killed a lot of things, plus volcanology, which was sort of like icing on the cake. And it killed 96% of ocean life, which is insane. That's almost all of it. And it killed 70% of life on land. And since not everything was killed, it was able to bounce back, because it always does, because we're still here. And it marked the beginning of the Mesozoic era. And so here at the Mesozoic, there's only 3 periods, but don't let that fool you, because there was a lot that was happening, because you see like Jurassic and Triassic, and if you know anything about dinosaurs, you know that most of the fun ones come from there. And so here are some more boundaries. You can pretty much guess that most of these boundaries begin and end with another mass extinction, as I said before. And so here we have the Triassic. And there was a really cool thing about the Triassic. So basically, as time progresses, life becomes more complex. We all know that. But the thing that sort of evolutionized these dinosaurs is they had a hip bone, and it pointed forward. And you might be like, well, what does this have to do with anything? But like this hip bone was really cool because if you check at any of these back legs of like any of these life forms here on the right, you can tell that they rely heavily on it, and they wouldn't be able to move around or do anything that they need to do without it. And at this time, also, life was getting complex enough where basically every part of the Earth was covered. Like before, it was like insects were limited to the sky, like only like the ones with wings could really fly around. But now you start to see like reptiles that sort of resemble like small pterodactyls were like able to reach the skies, which was crazy because it's never seen before. And the end of the Triassic was from primarily volcanism, and it was crazy because this volcanism was pretty long. Geologically, it was just it wasn't very long, but 10,000 years is a long time for any life to deal with. And it was guessed around like 10,000 years, like these volcanoes were spewing like poisonous clouds, shooting out ash, which made things colder for in certain areas, and it just made it generally hard to live. And then once that ended, it marked the beginning of the Jurassic. And this is sort of where dinosaurs really started to take off, and that sort of life. Because if you remember that hip bone I was talking about earlier, this time it pointed down, and you're like, why is that important? And this sort of made it so there was more areas in stomachs, and you're like, that's a pretty small thing. But for life at this time, that was huge, because the more things you can eat, the bigger you can get. The bigger you can get, the safer you are. The more safer you are, the more you can reproduce. The more you can reproduce, life lives on, and you basically are just more successful. And also what this meant that there could be more development in other areas. So things like the Quetzal, this giant like reptile bird-like thing, could just soar and take off, and it was huge. It was, I think the wingspan was like 6 meters, which is gigantic and scary. And we should probably keep going, but the end of this period was where Pangea was starting to break up again and started to separate into continents that we start to recognize a little bit more. Not quite, because it's still part of Pangea and it's just breaking up, but then it brings us to the Cretaceous period. And the cool thing about the Cretaceous period is life for dinosaurs was really like fully developed, and things like the Tyrannosaurus and Brontosauruses were sort of going to finding their niche areas. Like Brontosauruses dominated like South Africa area at this time. And since it was mostly reptiles, it's really cool when we see a bunch of mammals. And by a bunch, I mean it was mainly just like rodents and stuff, but that's more than there ever was before, And the reason why these guys were so cool is because at the end of the Cretaceous period was the Great Dying. And also, this was just another standard extinction event, except there was also a giant meteor that smashed into the Gulf of Mexico. And it's killed anything that was large, because they didn't have food anymore. And without food, then they can't live. And then if they can't live, then they die. But it was easier for smaller mammals because they didn't need a whole lot, and they were small anyway. So a lot of like the big environmental hazards were less damaging to their population. And with the Great Dying, marks the beginning of the Cenozoic era. And this also had... Oh, wait. Cenozoic? Yeah. Cenozoic. Oh, wait. Okay, this is the wrong timeline, but ignore that. We have... ignore this slide entirely. But we have the Paleozoic era. And with the beginning of the Paleozoic, you have the Paleogene. And it only has 3 periods again. But this one is like so dense, because the closer we get to recorded history, the closer we get to like understanding like what was happening more specifically. And I'm going to go even quicker than I have before. But so the early to mid Paleogene period marked, or we could start seeing more life forms that we recognize today. Like if you look in the bottom right, there was horse-like animals, and they had like 3 toes and stuff like that. Or just their family had an odd amount of toes, which is what horses are in. But a lot of life was sort of still recovering from the extinction, so in the beginning there was a lot less life that was happening. But also during this time, grasslands started to occur, and that was huge. And we'll get over to into the next slide. But also temperatures were on the rise. Like everything was getting warmer, which is great for life because life likes warm things because it means they don't have to spend as much um, resources into making sure that they can survive winter and stuff like that. And so the mid to late Paleogene period, you start to see stuff like, if you've ever seen the Ice Age before, you've seen this like rhino right here, or rhino-like animal, and you start to see more complex mammals, and you can see this guy right in the middle. He's starting to look awfully more like something you'd see like a squirrel or a very, very early lemur or monkey. And also there was a fern that ate up a lot of CO2, and whenever that happens, there is bound to be an ice age, and so that's what the Neogene period was probably started with. And so you start to see even more life. Like this guy starts to resemble an elephant. You know, that's awfully crazy how that works. And you start to see more things like deer and smaller rodents that we sort of recognize today. Like I'm sure they're extinct, the specific species, but they've evolved into more things that we see today. And a lot of the evolution into modern day animals that we see comes from the Neogene period primarily. And also, since like grasslands were fully formed at this time, a lot of herbivores had to sort of adapt at this time, adapt or die, because if they couldn't eat grass and have that extra like chamber in their stomach, which helped a whole entire species like cows sort of come to present day. And then we have the beginning of the Quaternary period, and this is like 2,000 years ago, basically, where monkeys and apes and stuff started using stone tools and like sticks to like now, to like recorded history now. And so a lot of the information you'll find will be about like how hominids were interbreeding with Homo sapiens, and we get to see all these cool things like woolly mammoths at the beginning of it, but now they're extinct. And we also have a lot of information, so this is very basic, and it brings us to modern day humanity. And I know I went a little over, but we also had to start from the Cambrian all the way to the Holocene, and I thought, yeah, I enjoyed researching a lot of this, and here my works cited. There was a couple YouTube videos that were really helpful, and yeah.